So I will open the solution in which I was working. So here if you see, let me process this table. Sometimes in your projects, you need to display the percentage share of a particular metric of with respect to a particular dimension member. So how you can do that is, let's say I will create a measure which will give me the percentage share of internet sales amount with respect to product subcategory. So there are different product subcategories, right? So let's say one product subcategory has the sale of that product subcategory is 20%. Another product subcategory, the sale is 30%, like that. So what is the percentage share of each subcategory with respect to the internet sales? So how I can create that measure is, after we create these measure percent of total, we will discuss how to implement many-to-many relationship and tabular SSAS. Okay, so let's say percent of total percent of total and per okay, percent of total internet sales amount per subcategory. So in my numerator, I will take the internet sales amount, and in my denominator, I will take the internet sales amount for all the subcategories, so that then it will give me the percentage of share. And and if I can do the division by a normal divide operator, or I can use the divide function. The advantage of using the divide function is it handles the division by zero error on its own, so I don't need to write any code for that. So that is why for division always use the divide function. You can see here save divide function with ability to handle by zero case, divide by zero case. Okay, now here in the numerator, it will be sum of internet sales amount. So it will give me the internet sales for each particular subcategory. So I am writing sum here. I can also write this internet sales amount only, which already does the sum. So, but just to be more clear, so it is the same thing. I am doing the sum in my DAX query. And see, the column name is sales amount. So in my numerator, it will do us, this is the table name and this is the column name. So in my numerator, it will do a sum of the sales amount. Okay, now we come to the denominator. Oh, sorry, I have to close the bracket. And now we come to the denominator. So in the denominator, I will write calculate, and then I will do a sum of the internet sales amount only. But instead of that particular subcategory, I will do a sum of all the subcategories. So that is the thing, that is the important concept here, that I am dividing by the sales amount of all subcategories by the, I am dividing the sales amount of an individual subcategory divided by the sales amount of all subcategories. So for all subcategories, I will use the all function there is one function called all. Team product subcategory English product subcategory name. So I'm closing the brackets. Now you see the logic here is I'm dividing the internet sales amount of a particular subcategory and I'm dividing it by the internet sales amount of all subcategories. So I'll get the percentage share of sale in each subcategory. And you can see it is coming as 1. So now I will change it to percentage. So for that I have to go to the F4 window, which is my properties window. Okay. Now here it is general, so I will change it to percentage, the format. And it is 2 decimal places. Okay. Now let me process the solution. Okay. Now let's say I'll open this in my Excel, so it will easier to browse. Okay, now here I will take the internet sales amount and the percent of total percent of sales. Okay. Okay. And let's say I will take the product subcategory in my rows. So this is the English product subcategory name. So if you see here that bike racks of all subcategories, it is 0.13%. Same with bike stands. So the helmets is a good sale. It is 0.77%. The maximum sale is road bikes, which is 49.46%. Then is mountain bikes, which is 33.90%. Okay, these two subcategories have the maximum sale. So this kind of calculations sometimes you need to do in your tabular SSAS. Okay, now this is with respect to the subcategory. Now let's say I want to do this kind of calculation for a year. So what is the percentage of sale in a particular year with respect to all years? So that also I can do. So here what you need to do is so here what you need to do is you need to use the divide function again. And in the numerator you will put the sum of sales amount. In this syntax, you should understand that the first is your table name, then it is your column name. Okay. Then put a comma and if, because right now I am writing the every time the correct syntax, so it is not giving me any error. But if you have written some wrong DAX syntax, it will give you an error. So for example, like this, see, if I go here, you can see it is giving hash error. So there is some error with the syntax. Okay. So and then you have calculate, and I will calculate the sum of sales amount for all calendar years. So I will take the year column. So order date year. Okay. So what it will do is it will divide the sales amount of a particular year with the sales amount of all years. Okay. You can see that the bracket which you're closing, the other bracket is getting highlighted. So that is very useful because you can understand which brackets you need to close. So this is the last bracket of divide. So these are the brackets. So that is very useful that I need to use so many brackets. Okay. And I will change this to percentage. Okay. Now if I deploy and process, okay. Okay. Now from my pivot table, I will remove these. Okay. Now I will take data, refresh all. So here I need to take the percent of internet sales per year. Okay. So and I will take the year on the rows, so it will give me the percent of sale per year. with respect to all years. So I will take this on my rows. So you can see here that for each year this is the sales amount and this is the percent of sales. So the maximum sale happened in CY 2007, 33.35%, then CY 2008, 33.328%, then CY 2006, and the least happened in CY 2005. So these kind of calculations you can do in your Tabular SSAS, and sometimes you need to implement these kind of calculations in your Tabular SSAS. So that is why I showed you how it can be done, how you can implement it. Okay, so the next important topic that we will discuss is how we implement many-to-many relationship in Tabular SSAS. Now, the many-to-many relationship was earlier a feature which was an inherent feature in multidimensional SSAS, but that feature was missing in tabular SSAS. And the developers, what they used to do in case they needed to set up the many-to-many relationship in tabular SSAS, they developers had to write some complex DAX code to achieve the many-to-many relationship. But since this was in the earlier versions of Tabular, which was I think Tabular SSAS was launched in 2012. So in 2012, this was the issue. Then Microsoft eliminated this issue, and Microsoft launched a feature called bidirectional cross filtering. So using this feature, developers can implement many-to-many relationship in Tabular SSAS. And this feature was launched in SQL Server 2016. So after that, now we can easily create the many-to-many relationship in tabular SSAS. So that is not a concern right now. So how we can develop the many-to-many relationship, I will show you. So if you remember, in our data warehouse, there is a dimension called dim sales reason, and that has a many-to-many relationship with the fact internet sales table. And the relationship is set up using a bridge table called fact internet sales reason. So if you look at the data, So if you, this is my adventure works. So here, uh, this is the fact internet sales table. This is my fact table, which contains all the all the sales happened through the internet. Now here, if you see that in this fact table, the combination of sales order number and sales order line number, the combination of these two forms the primary key of this table. Okay, so that uniquely identifies each record in this table. Sales order number can be the same for more than one record, but the combination of the for them the sales order line number will be different. So the combination of these two is unique with respect to our fact internet sales table. Now if you think about each record, for each record in this fact table, we have a order date key, we have a product key, we have a promotion key, we have a sales territory key. Okay, for each individual record. Now, if you, this is these relations that you see, the product key, the order date key, the promotion key, these are all foreign keys in this fact table, and they are related to the primary key in the dimension table. So it's a one-to-many relationship. One is on the dimension side, many is on the fact side. So it is a regular fact to dimension relationship, the usual relationship that we have in most of the scenarios. But this is a one-to-many relationship. Now, the complexity arises when you have a many-to-many relationship. So there is one dimension called dim sales reason. So this dimension, it contains all the reasons why the sale happened. Okay, whether it was due to magazine in advertisement, or television advertisement, or due to promotion, or due to price, or due to the manufacturer brand name. Okay, why the sale happened. So if you look at each individual record in this fact table, each individual record has a dimension key, right? A product key or customer key or order date key. But let's say for each individual record you have more than one dimension key. Then how will you represent that kind of data? So that is a many-to-many relationship. So for each individual record in the fact table, you have more than one dimension keys. The dimension keys are present in your dimension table, but you cannot form a simple primary key foreign key relationship between the fact table and the dimension table because it's a many-to-many relationship. Now, in order to uh, implement this kind of relationship, you need a bridge table or a mapping table. So the bridge table is the fact internet sales reason, which contains the mapping between the two tables. So you can see here as I said, combination of sales order number and sales order line number, the combination of these two provides one single record in our fact table, and that is related to the sales reason key. So each individual record in the fact table has more than one sales reason keys. So that mapping is done through this mapping table. Okay. Now if you, as I have already mentioned, the logic behind implementing the mapping table is that it relates to the two dimension tables. Okay, one dimension table, it is relating to, say, using sales reason key. The other dimension table, it is relating using the combination of these two. So the fact internet sales, it is actually acting as a fact table and a dimension table both. And this fact internet sales reason, it has a relation to the dim sales reason dimension, as well as it has relation with the fact internet sales dimension. And using these two relations, this becomes the mapping table. So using so the fact internet sales is related to the dim sales reason using this table. So as I had explained earlier, so there are you can say there are 4 tables in the picture. In the logic, one is the fact internet sales, which has a many-to-many relation with the dim sales reason. The intermediate table is fact internet sales reason. There is another table which is not physically visible to you, but that is the fact internet sales dimension table. So this is related to the fact internet sales dimension table and the fact internet sales their dim sales reason, and fact internet sales is related to dim sales reason via this table and the fact internet sales dimension table. Okay, so the logic is that it is kind of complex, but the logic is that fact internet sales is directly related to the fact internet sales dimension table. Okay, via the combination of these two columns. Now, fact internet sales dimension table is directly related to fact internet sales reason. Fact internet sales reason is also related to dim sales reason. Now, this intermediate relation, it helps in creating the relation between fact internet sales and dim sales reason. So our final relation is between fact internet sales and dim sales reason. So how we set up this kind of relation in tabular SSAS. So in multidimensional, we have the many-to-many relation option. It's an inherent feature in multidimensional. If you go to the dimension usage tab, you will find the many-to-many relation option there where you can set it up. Now here in Tabular, how you can do it is, first I need to bring in those two tables in my model. So for that, I'll go to existing connections here. So I need to select the two tables, which is fact internet sales reason and dim sales reason. Okay. So you can see here, this is the dim sales reason table and this is the fact internet sales reason table. Now, as I told here that for fact internet sales to establish the relationship, we need a combination of these two. Sales order number and sales order line number. So I'll create a calculated column which will form the concatenation of these two. So I'll rename this as order number and here it will be sales order number, then I'll put a space.
Mr. Saha,
Yes.
hello. Yeah,
Yes.
you have to select the whole column, right?
You have to select the whole column means?
The column, the new calculated column.
No, you can, without selecting, you can write it here.
Oh,
You,
okay. So if you even select one cell, the
it
what you
does
say,
not,
the formula applies on all.
yes. So
Oh, okay. All right.
it
Yeah.
does not depend on the selection.
Oh, okay.
So it depends
Yeah.
on what you write here in the expression. So
Okay.
it will apply to all the columns in your table. So that is
Okay.
that is the concept of calculated column. So when you create a calculated column, that calculation will apply to all records in your table.
Okay, that's new thing to know. Thank you.
So now if I close this, so now the concatenation that you're seeing of sales order number and sales order number, so I wanted to bring that to one column. So and this will apply to each and every column, each and every record in this table. It is not for any particular record or anything. It will do it for each and every record in this table. Okay. Now I need this same calculation in the fact internet sales also, because I need to set up the relationship using this column. So in the fact internet sales also, I need the order number. So here if you see, we had already created one calculated column. The only difference is I have written the line. So I will remove the line from here. The reason I want this to be same is because I will set up the relationship between these two tables based on this column. Okay, so you can see the order number here. So I'll rename this to okay. So now if you see here, if I go to the diagram view, and if I see the relationship here, see there is a relation between dim sales reason and fact internet sales reason table. This is a one-to-many relationship. The usual relationship which we have between a fact table and a dimension table. Okay. Now we also need another relationship between the fact internet sales reason and the fact internet sales table, right? So how to set up that relationship is here. So this is my internet mapping table. So I will set up a relationship with my second dimension table here, which is my second dimension table, the fact internet sales. And how I will set up this relationship is based on the order number. So that is why I created that calculated column. because based on that I will set up the relationship between these two tables. Okay, so now you can see that this mapping table, it has relation with this dimension table, as well as it has relation with the second dimension table, which is fact internet sales. Okay, so now uh, should the many relation work? Because I have the mapping table, I have relation between the with the mapping table, the two dimension tables, as well as I have relation with the between the fact table and the mapping table. So ideally our relationship is set up, and let's process and let's see if it will work. Okay, now if I go to my, let's say it is processing till now. Okay, now if I go to my Excel sheet, I'll remove all this. Okay, so now I have set up the relationship. I want to see the sales reason, and let's say the orders, the number of orders which were placed for each sales reason. Let's say what was the number of orders placed for television advertisement, what was the number of orders placed for a magazine advertisement, what was the number of orders placed for promotion. So I want that. For that I will create a order quantity measure in my fact internet sales table. So there is one measure called order quantity. So I will just do a sum of this and create the measure. So auto sum. Okay. So here it is just a sum of the order quantity. Okay. So why I created this measure is I want to see the order number of orders placed for each sales reason type. So how many orders were placed for promotion, how many orders for magazine advertisement, like that. So here, if I go to refresh all, this is my total order quantity. So my total orders is 60398. I want to slice this with respect to the sales reason. Okay, so I'll go to Tim sales reason. So here there is a sales reason name. So I want to slice this with the sales reason name. I want to check how many orders were placed for each sales reason. So if I check this, you can see the total order quantity is same for all the sales reason. So it is not working. So it is the same for television. It is not slicing the data. So why it is not slicing is because we haven't set up the many-to-many relationship properly. So here we have to go here, and here we see for dim sales reason the filter will go in this direction. It will, and from this table it will go in this direction to fact internet sales. But fact internet sales, the direction of filter is on the other side. So if you see here, the direction of filter is on this side, but I want it to work on the other way. So I need to set up a bidirectional cross filter here. This is the feature which was launched, and this is how we implement the many-to-many relation in Tabular. So here in filter direction, you need to select to both tables. Okay. Now you can see here that the filter will work in both directions. And now if I deploy and process it, okay, now if I go here and if I refresh all, you can see now it is working. Why? Because I set up the bidirectional cross filter to set up the made-to-many relation properly. So for manufacturer brand, the orders placed were 1818. Most of the sale happened due to the price factor. For promotion, these were the orders placed. For television advertisement, these were the orders placed. For quality, so this is how you set up the many relationship. Now let's say I want another kind of to do another kind of analysis. I want to see the uh, I want the uh, filter to work another way. So what I want is the order number, which is the concatenation of sales order number and sales order line number. I want what is the count of sales reasons for each order. Okay, so I want to display the count of sales reasons for each order. So we know that since this is a man-to-many relationship, in some for some records, the count of sales reasons will be more than one. So that is what I want. I want to see. So for that, what I need to do is I need to create a count measured in the dim sales reason. So this is a sales reason name. So I'll create a count measured. So here if you see, this is the sales reason count. Okay, now you can see instead of count, it is count A. So the difference between count and count A is that count counts all the records, and count A counts only those records which has not null values. So it excludes the null values from its calculation. So that is the difference between count and count A. Uh, so so this will give me the count of sales reasons. So what I want to check is for each order, what is the sales reason count? Okay. So for that, so here I will do the, if you think about it, so here I need to get the sales order count. I need to process the model. So I take the sales reason count here. You can see it is 10, and I want to check the sales reason count for each order. So I take the order number from my fact internet sales dimension. So this is the order number. Okay, so I want to see the number of sales reasons for each order number. So I will check that. And you can see here that for each order number, it is not slicing the data. It is the same issue which we had earlier. So we are not getting the sales reason count for each order number. Why? Again, the same issue, because we haven't set up the bidirectional cross filter for this calculation. So here, from this sales order number, there the filter has to work till the dim sales reason. So for here, this needs to be a bidirectional filter. So this now, if I process this, there's a very, I would say, one of the uh, very good enhancements which Microsoft has done with Tabular SSAS, because earlier main-to-many relationship, it was very kind of a little bit difficult to set up that kind of relationship in Tabular. So using this feature, we can set up this relationship in Tabular.
Indra.
Yes.
So this bidirectional filter, is it only like used for many-to-many relationships, or we can also use for one-to-many and many-to-one relationship?
No, let's say usually in 90% of the cases, you will need to filter from dimension table to your fact table. Okay, so the direction of the filter will be based on the values of your dimension table. You want to filter the data in the fact table. That is the usual way we slice and dice the data. But let's say you have a requirement where you want the filter in the other direction. There is some attribute in the fact table. Based on that attribute, you want to filter the data in the dimension table. So that, though that is very rare, you will not frequently come across that kind of requirement. But if you have that kind of requirement where you want to filter the dimension data based on the fact data, then you can use the bidirectional filter.
Okay, thank you.
Okay.
Mr. Saha,
Yes.
I'm not pretty sure about how the data flows. Can you please explain it?
Yes, so you can see here that this is for each order. Now it is working. The sales reason count is 2. So for this particular order, there were 2 sales reasons. Similarly, there, if you go down, you can see for these orders, there is only 1 sales reason. So so for this it is 1, for this it is 2. So this is how the bidirectional filter is working. Okay.
Mr.
So
Saha,
yes, tell me.
actually, I'm not clear about in which direction like the data flows.
In which direction
How
the
do you
data
know that
flows?
in which direction data should flow?
Because you have that, no one will be able to tell you. You will have to check the data and understand. Because that is something which you have to analyze the data and understand. There is no, see, the direction in which data flow, the most of the times you have a dimension table and a fact table. You have a primary key in a dimension table and you have a foreign key in a fact table. So it's a one-to-many relationship, and most of the time when you are filtering, then it will be from the dimension table to the fact table. That is the regular relation. Now that is the now how when to use bidirectional filter, that no one will be able to tell you. You will have to analyze and understand the data, and then based on that you would have to use a bidirectional filter if it is required. It might not be required in your model. There might not be any requirement of a bidirectional filter. If the filter only works in one direction, it might work fine. So you would have to analyze yourself and to find out that if you need a bidirectional filter or not. Maybe in 90% of the cases we don't need a bidirectional filter, because most of the time we filter from dimension table to fact table. That is the usual way we filtering is done in a data warehouse project. So most of the time you will not require it. You will require it if you need the filter to work in the other direction, or if you need to set up a many-to-many relationship. Now how the data is flowing, that you will have to analyze and find out.
Does it depend on how we do the slicing and dicing?
Yes, of course.
Yes.
See here, the filtering that I am doing, that is in the other direction, because this is coming from the fact table and this is coming from the dimension table. So ideally this is a rare case. Ideally this kind of filtering you will not see. This is
Right.
this is very rare because this is coming from fact table, this is coming from dimension table. Usually we filter the other way around, where this is coming from dimension table and our measure value is coming from fact table. Okay, usually we follow that direction, but I just wanted to show you how the bidirectional filter works. That is why I showed you this example. But this is not very common. It is very rare, I would say.
Okay, now I got you. Thank you.
Okay.
Mm-hmm.
Okay, so the next thing and the last thing that we would discuss today is how we create partitions in Tabular SSAS. So for that, we'll take a 5 minutes break and then I'll come back and then I'll discuss that topic. Okay. Okay, so I'm back. So now the next topic that we would discuss, that is a common topic which we have already discussed with multidimensional. So it is kind of similar in tabular as well. So if we can implement the same thing in tabular, that is called partitions. So the same reason applies to here as well. Why we create partitions, it is one thing is if you have a lot of data, then it improves the query performance, and second thing is processing performance. So if you have a lot of data, you can create, let's say 10 years of data, you can create yearly partitions, and if on a daily basis you don't need to process all the partitions, you can only process the recent most partition. Okay, so that is the benefit. So that is the same benefits that we had with multidimensional SSAS. With partitions, the same benefits we have with tabular SSAS. And the way we create the partitions, that is also kind of similar. So let's say for fact internet sales, I'll create multiple by default one partition is created which contains all the data. Now I'll create multiple partitions for fact internet sales. First let me check the minimum and maximum order date key in the fact internet sales table. Okay, so the data is coming from 2005. So we have data from 2005 calendar year. And if I take max, two 2008, so I have data from 2005 till 2008. So let's say if I want to create partitions, you can see here, you go to table and go to partitions. So here you can see at the moment there is only one single partition which contains all the data from fact internet sales. Now let's say I want, okay, I'll remove the top 1000 from the select table, and here, or based on the order date key, I'll create the partitions. So the first partition will be order for 2005. So this will return me all the records from 1st January 2005 to 31st December 2005. Okay. Now let me take this query and here. So I will replace this. Okay. Validate design. Okay. And I'll rename this to fact internet sales 2005. Okay. So now one partition is created for 2005. Now same way, I'll just remove this comment. Okay. And I'll create a new partition for 2006 now, so I need to click on the new button. Okay. And here I need to put the query. So here I'll put 2006 and 2006. So this will give me the partition for 2006. Validate design. So as you can see, it is kind of similar to the partitions in multidimensional. So very simple. There is nothing complexity about that. So you can go to table partitions. You can see this is last processed when the partition was last processed. So I'll select another one for 2007. Seven. Okay. 2007. And last partition I'll create for 2008. Okay. The factory internet sales 2008. So you can see the, let me process and deploy and process it. So if you see here, so if I take the internet sales amount and if I take the order, so this is my order date calendar hierarchy. It is on. Okay, so you can see 5, 6, 7, 8, all the 4 data I have. I have created multiple partitions instead of single partition. Okay, so that is how you can create partitions in Tabular as you can create it with multidimensional SSAS. So it is kind of the same feature, you can say, is present in both. Then the next feature that we would discuss that is also common to both, that is perspectives. So here also, if you want to hide some objects from a particular view, you can do that using perspectives. So it is the same thing which we had in multidimensional. So you can create perspectives here also. So here also you can see you can create translations the same way which we did in multidimensional. So here also you have perspectives. If you select default, it will be your entire cube. So let's say I'll create a perspective and new perspective. Let's say I want to create a perspective for finance department. Okay, so if I want, I can, let's say I want to check these particular attributes, but I don't want to display the customer alternate key or the customer key and the email address of the customer. Okay. First name. So these are the things if I want to display. The dimension, let's say I want to display all the attributes of our dim product. If I check the dimension, all the attributes for dim product will be checked. and then if I go to fact internet sales, here I can say select what I want to display. Like if I want to display the order number, sales order number, sales order line number, and see, these are the measures that we created. So I want to display the measures that we created. So this is how you can create a perspective. And if you right click and deploy, okay. So here if you go to your queue, let's say, okay. So here if I click on analyze in Excel, you can see that it is giving me two options. Model is the entire cube. So it contains everything what we have developed till now. Finance is the perspective. So which some objects we have checked and some objects we have hidden from it. Okay, so you can choose the perspective, and let's say for your reports you can create a perspective which and uncheck the objects which your customers don't want to see. Okay, you can uncheck them, and then you can provide the perspective to your customers, so they will not be able to see those objects, and they will also not know that those objects exist in your cube. Okay, so this is how you create partitions and perspectives in SSAS. So we are almost, so the last thing that we would discuss is how to create a KPI in Tabular SSAS, and I will also show you how we can extract data using DAX queries. Like if you remember, we extracted the data from the cube. We wrote some select queries in MDX. Similarly, you can write and extract data using DAX queries also. The syntax is a little bit different, but you can write and extract data using DAX queries also. So the next day we will cover how to create KPIs and how to extract data using DAX queries. Okay, so any questions you have regarding what you have discussed till now?
I have one question here, and
Yes, tell me.
in that perspective, same analogy like views in SQL,
Yes, there
and
is
the main purpose is for security or for performance.
no, the main purpose is, I would say, not for security. The main purpose is if you do not want to display some objects, it is from the visual point of view. Let's say you have a very big cube. Okay, you have lot of measures, a lot of dimensions, which sometimes are, those some measures and some dimensions might be irrelevant to some people. While they might be relevant to some people, they might be relevant to other people. So in that case, what you do is you can create a perspective so that the customers to whom these measures and dimensions are irrelevant, they do not see those measures and dimensions. It is just from the display point of view. So it is very similar to the view of a cube, and from like performance, it does not improve the performance of the cube. The performance would be the same, and security also, like you can implement security is different. You can implement role level security in multidimensional as well as in tabular. So for that, we do not use perspectives. So for security, we create roles, and in roles we specify that the members of this role will not be able to view this and that. So for that we create roles, not perspectives. So security is like different. It is only for display purpose.
Got you. Thank you.
Okay.
And the other question I have
Is
uh,
yes, tell me.
if you open up the diagram, the relationship diagram,
Yes. Yeah.
if we have like three relationships from fact to dimension, like
Yes.
one active and two inactive, for
Yeah.
example, on eighth
Yes.
dimension. Yeah, right here. How
Yes.
can we activate the other inactive dimensions whenever we want and when we use them?
Yes. You can.
And the
You
other
can.
question, which I need to answer, I need you to answer both of the questions same time. So the other thing, right here we have only one fact table.
Yes.
If we have two fact tables or three fact tables, I guess we have three relationships from each fact table to the dimension table, especially with the bit key, the bit
Yes.
dimension.
Right.
So how can we handle that?
No. See, the thing is that you can enable any of these to any time, but at a time, as at a time, you can only have one active relation. So let's say if I make this relation active, then I will have to make this relation inactive. So at a time only one relation can be active. So if I say, let's say, if I right click and if I make this active, okay, you see it says deactivate or delete the exit to create another one. So at a time you can only have one active relation. So the way how to handle this is, if you remember in our last session we told how to create role-playing dimensions. So for this order date we created role-playing using calculated table. We created a due date table and a ship date table, and using that we connected the due date and the ship date. So ideally I don't need this anymore now, because I already have two separate tables for due date and ship date. So in tabular at one time you can only have one active relationship. So let's say if I make this inactive, then I can make this active. So if you see here, now the relation is based on the ship date key. Earlier it was on order date key, the active relation. So like that. So ideally, if you are creating role-playing dimensions, you like using calculated table, you don't need these inactive relations. You can delete them and you can create role-playing dimensions using calculated table concept.
All right, thank you. Gotcha.
Okay. Alright, so I will end today's session, and tomorrow we'll discuss KPI and DAX queries and how to implement security in Tabular SSAS.
Okay, thank you, Indra. Take care. Bye.
Bye.
All right, thank you. Have a good day.
Mr. Saha,
Yes, tell me.
be strange, right?
Yes, right. 1 second.
Yeah.